Now, error is the difference in magnitude between a measured value and the true value. Now, absolute error has a symbol of E. Now, absolute error is not a type of error, it's just an error. It's a form of error, but it's not a type. When it comes to types of errors, we have three types of errors: determinate error, indeterminate error, and gross error. So, absolute error is not a type of error, but it's a form of an error. So, what is this guy? This is xi minus xt. Now, where xi is the measured value and xt is the true, accepted, or actual value. Now, the xt is the true, accepted, or the actual value. Now, how do you solve for relative error?
Is that inch?
Relative error. Now, relative error is absolute error divided by the true value. Absolute error all over true value. Now, what is absolute error? Xi minus what? Xt. Now, what is the true value? Xt. Class, listen and listen very carefully. This relative error in exam, they can choose to ask you percentage relative error. You can say solve for the relative error in past state also. You can say solve for relative error in past state linear. Those percentage, those thousand or those million is just an extra stuff to be added. But you must first of all know the formula for relative what? Error. So if it was to be relative error in percentage, this would have been times what? 100. In fact, 1,000, this would be what? 1,000. Now, I'm going to solve the question that came in this one we just completed now before we get to types of errors. Right? Now, class, that question number 27 from last year, the question C was determine the percentage determine the percentage relative error. Class go. Let me just remind us the values. Xi is the values for that particular question, the values, data value that was given to us in that question. Please read out 19.1. Now, these are the six parameters given to us. If you are asked to solve for the percentage relative error, that is why. Look at this question. It's very simple, but it's very stressful. That means you're going to do the error for each of them. For this guy, for this, for this, for this. How many times? 6. Now, in that same question, they told us that the actual value, you cannot solve for relative error without giving the actual value. Because relative error is measured minus actual, right? Please, the actual value in that question, actual value, which is xt, is equal to what? It was in that question. 20 point what? 20.0 ppm. Alright, so that is the value. You are asked to solve for the percentage relative error for 19.4, 19.5, and the rest. So please, I'm going to solve for one here. I'm not going to solve for 6 of them. I'll just solve for 1 or 2, and then obviously you understand how to solve for the rest. You also, in the exam, please don't waste time in one question. Next up, solution. Now, relative error in percentage is equals to xi minus xt now I'll say I for the first value. Remember, we're going to solve this for one value. for 19.4, this is the first parameter. Remember, all this guy here, XC, which is a true value, true or actual value, is going to be constant all throughout the calculation, right? The true or actual value is 20.0 ppm. So for this guy, for the first one, our XI is going to be 19.4. Now our XC is going to be 20.0 ppm. Now ER in percentage, but I don't have to write it this way. I can simply say percentage ER, this side is percentage, is equals to XI for this first one is 19.4 minus 20.0 divided by the true value is still 19.4 times what? 100.
Oh, 20.0.
Oh, please. The true value is 20.0. The true value is 20.0. 19.4 minus this is going to be minus 0.6, right? Please press the calculator for me. The answer is going to be minus. Alright. Now that's for the first one. Now for the second one, we are still going to do the same thing, class. For the second one, the second value here is 19.1. Remember, in this case, our XI will be 19.5, right? Our XC is constant, which is what? 20 ppm. This guy is constant. So my ER, percentage ER, is XI minus XC over what? XC times what? 100. This is equals to XI is 19.5 minus right now is the percentage error, percentage relative error for the second one. So in exams, you're going to do it for the first, do it for the second, do it for the third, do it for the sixth, and then that is it. We have the third one, gross error. Determinate error are errors that causes the mean of a data. They are errors that causes the mean of a data to differ from the accepted value. This error is characterized by the closeness of agreements between the measured value and the true value. It characterizes the closeness of agreement between the measured value and the true value. Determinate error affects the accuracy of a result. It affects the accuracy of a result. This error is as a result of personal mistakes, sampling methods. Now look at this class. We said that determinate error affects the result of an analytical result. Now what do I mean? If the measured value, for instance, let's say if a true value is equal to 50 meters, or let's say something actually, and then you actually go and measure this length, and then you're having maybe measured value 47.8. and you're having another one. The same, when they say replicate means I'm carrying out the same measurement, the same way, like I did the first one. So obviously the answer is supposed to be closer, right? So imagine that the next one I have 48.5. Class, look, these are the first, this is the first attempt, this is second attempt, it's not so. Now, this is actually the true value. So now, if I want to measure the error of this guy, if I compare this measured value to this guy, you realize that between these two values, which of them is more accurate, class? The second one, right? Because this guy is close to this true value. Is it not so? So any error that characterizes the closeness of measurement between two values, right, is a determinant error. Because it affects the accuracy of the measurement. Right? It affects the what? Accuracy. Now, what is accuracy? What is accuracy? Please go down. Accuracy is the closeness of a measured value to a true value or accepted value. Let's say, for example, true value is also this is x. The actual let's say the true value of the substance is 4 grams, and then you go ahead to reweigh that stuff, and you're getting 35 grams. Another person reweigh that stuff is getting 38 grams. Now, if you look at this, you can say that the second value is more accurate, right? Because you're comparing this measured value to a true value, right? Because it's close, we say it's more accurate than this other one. So that is that for determinate error. Let's look at indeterminate error class. Now we have indeterminate error, which is also known as random error. Indeterminate error are errors caused by uncontrollable or unpredictable fluctuations in variables that affects the experimental results. They are caused by uncontrollable or unpredictable fluctuations in variables that affect the experimental results. Indeterminate error affects the precision. Indeterminate error affects the precision of the measurement. It affects the precision of the measurement. It affects the precision of the measurement. It affects the precision of the measurement. And are characterized by random variation in their magnitude and their direction. And let's look at precision. I told us that this guy affects the precision of the measurement. Determinate error affects accuracy, right? Indeterminate affects precision. Now, what is precision, class? Please do that. Now, precision is the closeness of two or more measurements to each other. Closeness of two or more measurements to each other carried out in the same way. Closeness of two or more measurements to each other carried out in the same way. Closeness of two or more measurements to each other carried out in the same way. Now, so let's see if I have 19.8, 2.5, 17.2, 3.6. Now look at this. Imagine you carry out 4 replicate analysis and you're getting 19.8, 2.5, 17.2, 3.6. It simply means that there is an error here. And this error is going to affect the precision. Do you know why? There's no true value. As if they are giving us true value, right? We would have actually checked out and say it is close to the true value. If it is close to the true value, you can now say, oh, comment on the accuracy. But since there is no true value, now look at this. Imagine they give you something like that and they say, comment on this. Which type of error is this? Now this is random error. Because random error, I told us that they are characterized by random variation. in their values. This guy is scattered. This one is smaller than this. It is actually scattered. They are actually random. You know so. So anytime values are scattered this way in a random manner, the error that affects that guy is what? Indeterminate or random what? Error. Gross error is an error that affects only one single result in a set of data. An error that affects only one single result in a set of data. Error that affects only one single result in a set of data, causing it to differ significantly from the remaining results. An error that affects only one single result in a set of data, causing it to differ significantly from the remaining results. Causing it to differ significantly from the remaining results. Now let's assume, for instance, I have 4.10, 4.11. Now look at this. Before you write this, gross error, there's one. This gross error characterizes an outlier. It characterizes a what? An outlier. What is an outlier? When they say something is lying outside, it means it's not part of the trend. It's not part of the what? Now, an outlier, listen, an outlier can either be the smallest or the what? Highest. That's why it's called outlier. It cannot be in between. It's either you're the smallest or you're the what? Biggest. Alright. So let's assume these four values here. If you notice, the first, the second, and the fourth, right? They are similar, they are close. But then you have this third guy, which is totally different. This guy is lying outside the plane, right? So in this case now, this guy is the what? Outlier. Alright. So there's a question I would like to solve from the past question. Please open it for me. Now, please look up. They said this is from your past question 2 years ago. Analysis of total calcium level in soil in milligrams per kilogram at 3 different sites yielded the following results after 4 repeated measurements. We have site A, site B, and we have site C. Now for site A, remember we said 4 repeated measurements. So we have these are the 4 values 1, 2, 3, 4 for site A. These are the values for site B. These are the values for site C. Now in exams, you might decide not to treat us in terms of table. You can just look at notes, right? Now they said if the true value of calcium in the soil at the 3 different sites, that means for each site, they know actually the true value for calcium, right? For site A, the true value is 2.65, right? For site B, the true value is 2.40, and for site C, the true value is 4.05. And the question says, comment on the precision and accuracy in the measurement. Please, I want to add this, and also, please don't add it up. The reliability of the data. Now, I'm just adding this one here. Comment on the precision and accuracy in the measurements at the 3 sites and also the reliability of the data. Now, is this data reliable? Can I actually work with it? Can I not work with it? All right. Okay. So let's look at the next one. Determine the relative error in past 1,000 for each of the 4 replicates measurement. Please, I'm not going to solve this B. Now, what this B simply means is that they say determine the relative error in past 1,000, right? For each of the 4 replicates measurement in site what? C. So come to site C here. The value for relative error is xi minus what? All by x times 1,000. Since they asked us to solve this in past 1,000, right? Now this is going to be, for this site C, the first value is 4.0. Remember, in site C, the true value for site C was 4.05. So they gave us true value for site C. So I'll say for this first value, 4.40 minus 4.05, right? Divided by 4.05 times what? 1,000. That will give me, so for the first one, which had for site C, these are not solving this, I'm just giving us the example. We are also solve for the big, this is what I want to talk about. This is what I'm talking about. But let me just start to solve for this B. So site C we have, this is the first value for site C. So also, now 4.40 minus X is true value. True value for this is 4.05, right? So we have 4.05. True value is 4.05 times what? 1,000. Please, what's the answer there? 86 point what? 40. Please, PPT. We want to put this. Because if it was percentage, you would have added the sign. But since the same times 3,000, you say if you what? See. Now, this for the first measurement. You're going to, because it's saying for each. So for the first one, we've done it. For the second guy, I'll say 4.10 minus 4.05 divided by 4.05 times what? 1,000. Okay. Now, let's look at, I'm not going to solve this C because I've already done standard deviation. They ask us to solve for standard deviation. This question, to tell you that is why you don't need to waste time in one place. They say, determining the standard deviation of each what? Sign. Meaning that you're going to consider this guy, solve for this, separate, come back here, solve for this, separate. Let's comment on the precision and accuracy of this guy. I want everybody to pay attention to that. First, what is accuracy? And also, what is precision? So let's say for site A, I'll talk about the accuracy and precision. For site B, I'll do the same thing. Accuracy. Let's stop. Let's like this. Stop right. Now, we want to comment on the accuracy class. For you to comment on the accuracy, you must have in mind or you must put into consideration the true value that was given. Right? Because you cannot comment on the accuracy without taking into consideration the true value. For site A, the true value for site A is 2.65. Right? So let's take this guy. For site A, the true value for this guy is 2.65. For site B, the true value is 2.40. For site C, the true value is 4.05. Now look at this. If you want to comment on the accuracy, you must put this into consideration. If you want to comment on the precision, you don't need this. Right? Now, accuracy is the closeness of the measured value to the what? Now, the measured value, look at this. 2.75 is close to 2.65. 2.60 is close to 2.65. 2.65 in fact less than 2.65. 2.70 is close to this. So if you look at the values in this side scale are close to the true value, right? So in terms of accuracy, the accuracy is high. So here, side scale, accuracy is high. Class covered. There is one other question they did not ask us here, which I want to put it down here. I'm not going to write, but listen. What if they had asked us to comment on the type of errors that is possible in this site? You just don't, I mean, comment on the type of error possible here in the site. Now, leave them gone. Determinate. Why? Because the major values are close to each other, and then close to what? True value. So this they have being what? Determinate error because this guy is close to what? True value. But it don't ask us for that, so we just focus on the accuracy. Since these values are close to the true value, the accuracy is high, right? Now let's also talk about the precision. Precision is the closeness of two or more measurements, right? These values are close to each other. This is close to this. This is close to this. So for themselves, they're also close to each other, right? So precision is high. Accuracy is high. Precision is also what? Precision is high. Claps. If precision is high, it means that the value is reliable. If precision is high, it means what? Because once precision is high, it means okay, I did the experiment the first time, the second time, and the answer is close to each other. It means that I did the right thing. I can rely on that value. Imagine you did the first one, the answer is giving you 5. The next one is giving us 10. The next one is giving us 20. Can you rely on that value? No. So these guys, precision is high. This data is reliable. Is it not so? Now that is for size A. For size B, now what do you think about the accuracy? Is accuracy high or low here? It's low. Because they show the values here are not really close to this true value. This each of them, they are not really close, right? So in terms of accuracy for size B, accuracy is low. Is precision low as well? Yes. No. How will you say no? Because let's say I can calculate this guy to what? 2. Can also calculate this guy to what? 2. So this guy is actually close to each other. Very logical question. But in terms of accuracy, it was not. But in terms of precision, it's kind of close. 2, 2, 2, and 3. So I would say precision is actually what? It's not high. Let's not debate from this. We don't have time to crack it. Now, side C, if you look at this side C, class, how do you comment on this? Is accuracy high or low? It's high. Apart from the outlier, right? Apart from this outlier, these values are close to what? The true value. Accuracy is high, precision is also what? High. Apart from the outlier.
So does that mean when accuracy is high? Does that mean if accuracy is high, precision is high? No.
It's what?
High. No.
Take it again. If accuracy is high, precision is high, what?
Does that mean? Yeah.
No, it doesn't work that way.
Different.
And but once accuracy is high, it's always very hard for you to see precision that is low. Once accuracy is high, it's very difficult for you to see accuracy and precision low. Right? Because for accuracy to be high, they are close to the true value. So if all of them are close to true value, that means they are close to themselves. Do you understand? So you hardly see high accuracy that will give us low precision. But you can see low accuracy that will give us high what? Because in this case now, accuracy deals with a measured value. I can have 1.1, 1.2, 1.3, 1.4, and let's say true value is 2.0. This guy is not close to this, right? But these guys are close to one another. So in this case, precision is high, accuracy is what? Low.
So does it mean that if precision is high, that is not
Reliable, yes. If precision is high, it simply means that remember precision is closeness of two measurement, right? So if they are close, that means I can rely on that value. It's just like somebody having